Hello, welcome back. Okay, so you may wonder why I've got so many problems with this, or why we're doing so many problems. And the reason is because all of these problems that I'm doing, sort of each one of them takes a different approach to solving, finding these regions, okay? This one's another one, it takes another different approach. And the whole thing here, what's difficult is dealing with this lemniscate. Not difficult, but what's new. What's new is dealing with this lemniscate. This, just a unit circle, excuse me. Like I was saying, this is just a unit circle. That's not hard to graph. This, though, we have to do something to graph that. Okay, so let's go ahead and do that. So the way I'm going to do this, I'm going to make a chart. Now, one of the things is I'm going to actually have two values of r. I'm going to have, for each value of theta, I'm going to have plus and minus r. Okay, and let me just, this is going to help me. Okay, I'm also going to do, that'll just make it a little easier. Okay, so the first one I know, r equals 0. That's easy, hopefully. Sine of 0 is 0. 2 sine of 0 is 0. R values are going to be 0 and 0. Okay, now let's think in our unit circle. Now what's the next angle we know? We know the sine of pi over 6. But we're going to have half of that because we're multiplying it by 2. So theta is pi over 3. Sine of pi over 6 is 1/2. 2 times sine of pi over 6 is 1. And so our r values are plus and minus 1. Okay? Sort of a little counterintuitive, but that's one of the things to learn how to do. Okay, one of the good things about math is it forces you to learn how to think counterintuitively when you need to. Okay? Okay, next. The next angle we know is pi over 4. So that means we want half of that, pi over 8. Sine of pi over 4 is root 2 over 2. This is root 2, 2 to the 1/4, negative 2 to the 1/4. Okay. The next angle we know on the unit circle, pi over 3. Half of that is pi over 6. Okay. 2 times sine, or sine of pi over 3. Sine of pi over 3 is root 3 over 2. So this is going to be root 3. 3 to the 1/4, negative 3 to the 1/4. Okay. The next angle we know on the unit circle, we know the sine of pi over 2, right? Sine of pi over 2 is just 1, right? So the next angle we want is pi over 4. 2 times sine of 2 times pi over 4 is 1. Oops, sorry. Yeah, that was 1. This is going to be 2. Root 2 minus root 2. Okay. Next angle we know, 2 pi over 3. But we want to remember, we want to divide that by 2. So it's just going to be pi over 3. Okay, that's again root 3 over 2. Root 3 here. 3 to the 1/4, negative 3 to the 1/4. Okay. Next one. The next angle we know on the unit circle is in that third quadrant, or in the second quadrant, 3 pi over 4. Divide that by 2, 3 pi over 8. Sine of 3 pi over 4, root 2 over 2. Okay, the next angle we know, 5 pi over 6. 5 pi over 6 divided by 2 is 5 pi over 12. Sine of 5 pi over 6 is 1/2. So it's going to be 1. So we're going to get plus and minus 1 for r. And finally, pi. Half of pi is pi over 2. Okay. Sine of pi is 0, 0, 0, 0. Now, we don't go beyond that. Okay, why? Because if we go beyond that, we're going into the third and fourth quadrants where sine is negative, right? And if sine is negative, we can't solve this. So remember, we need to basically say that our r values have to be, our 2 sine of 2 theta has to be greater than 0. Okay, so 2 theta has to be between 0 and pi. Theta then has to be between 0 and pi over 2. Okay, now we're going to graph this thing. Okay, we're going to graph by taking, something went wrong. I said pi over 3 here because I was doing pi over 6. That should have been pi over 12. Huh. Should have known better. Okay, so now I'm going to start graphing this. The way I'm going to do this, I'm going to take an angle. I'm going to say this represents pi over 4. Okay, that's an easy one. Okay, now I have 1, 2, 3 lines before pi over 4, 1, 2, 3 lines after. So I'm just going to draw those in. Pi over 12, pi over 8, pi over 6. Okay, and I have 3 lines after as well. But it gets harder to draw those in. Okay, now at pi over 12, what is the r value? The r value is 1 and negative 1. Oh man, I should have gone this way too. I'm just as frustrated as you are with myself right now. Okay, so now, when r is pi over 12, you're out at 1, and you have a negative 1. Okay, 1 and negative 1. When r is at pi over 8, you have 2 to the 1/4 and negative 2 to the 1/4, which is actually bigger than 1. Right? Maybe I shouldn't have gone out so far, but oh well. When you have pi over 6, you have 3 to the 1/4 and negative 3 to the 1/4, which is bigger than that 2 to the 1/4. Yeah. At pi over 4, you have the square root of 2. Okay, so you have to compare the square root of 2 with 3 to the 1/4, but it's actually bigger again. I didn't give myself enough space at all. Okay, and now it's going to come back down on as we go back up, right? Because look, at pi over 3, you got that 3 to the 1/4 again, just like at pi over 6. Okay? Okay, so this is sort of what our lemniscate looks like. And you have the same sort of thing going on over here. Off the page. Okay, nah, it's very ugly. Okay, but I can live with ugly. I just need to know I just need to get an idea of what's going on. Now, we also have a circle of radius 1. Let's make all this, oh, this is terrible. One more try. There we go. Now I need to make that circle bigger, actually. There it is. Okay, because it needs to intersect with that point here, pi equals, or when theta equals pi over 12. Okay, so now I'm going to go to another page just to sort of magnify what's going on, because we're trying to find the region bounded by these two curves. Okay, so what does that mean we're finding? We're actually finding this region. And actually, it's two of those, right? Okay, so let's go to a new page. We're going to magnify what's going on here. Okay, first, we know actually where these two intersect. Just from this, we know they intersect at pi over 12 and 5 pi over 12. Okay. Okay. We know actually between those points, let me draw it a little clearer. Here and here. Okay, this is actually just the arc of a circle. Okay, so this part's actually pretty easy to find. Okay, so let's call that, let me magnify this in a new page. I'm not going to really try to get this perfect, but I'm going to try to get like the vision of what's going on. So we have arc of a circle here. This is pi over 12, 5 pi over 12. We could find that area pretty easily. That area is going to be, what's the difference? 5 pi over 12 minus pi over 12 is 4 pi over 12 pi over 3. Okay, times r squared, r equals to 1. Okay, we also have this little stuff going on here. We need to find this region. Symmetry means I can just find this part. Okay, so what am I going to have to add? Two times the integral from 0 to pi over 12 to sine 2 theta d theta. This is, remember, r squared of theta, right? Okay. So now this is still not our total answer. Okay, so let's call this 2 times A3 or A1. So this is A1. This is A1. We also have the whole entire thing over on the other side. So what do we have? We have, for both sides, we have 2 times pi over 3. Okay, that's the pieces of both circles, plus 2 times the integral from 0 to pi over 12. That's for the two sides. 2 sine of 2 theta d theta. So that's our total answer. There's no hard integral there, so I'll leave it for you guys to complete. Okay? We're going to come back and do arc length. See y'all in the next video.